Let's explore a bit more about the gravitational potential difference. For that, we are taking up another practicals. So here we are using two planks with the same height, a cardboard and a ball bearing. There are two different cases, case 1 and case 2. In case 1, we have set up the board on the plank. Remember, these two planks are of the same height. In case 2, we have placed the system on the ground, right? So now let's look at the question. In which direction will the ball bearing move in both the cases? So I would like you guys to pause and take a second and think over. I hope you guys thought about it. Let me show you guys the answer. So once I play the video, you make your observation and come to a conclusion. So what's happening in the experiment? So once I gently I have placed this ball bearing at point A in both the cases very slowly. So what we saw here is the ball bearing did not move. But the question is why? To explore this, we'll be making use of the potential energy and potential difference concepts. So let's begin by talking about point A, point B, and point C's potential energy and potential difference. Okay. Please make a note that point B is front of point A and point C is back of point A. So basically, surrounding point A is what we have to discuss. Okay. In and around point A is what we have to look at. So first thing first, potential energy at point A. So since it's gravitational potential energy, it is mgh. Mg is your weight of the ball bearing. H is the height. Since the plank is placed at the same height, what do you think the potential energy at point B is? It's the same, is it not? Height won't change, mass won't change, and acceleration due to gravity in this space won't change. Is it not? Because all of these points are on the same height as we have done it so. So potential energy at point C is also same. Now, what is the potential difference between A and B? So this happens to be 0 joules. What is the potential difference between A and C? Even this happens to be 0 joules. Okay, so all of this space potential difference happen to be 0 amongst them. So if the potential difference happens to be 0, right, in this space and in this space and basically all of this space, the ball bearing won't move. Okay, so if we expose any object or if we place an object at rest, which is to be at rest at a point wherein the potential difference around it happens to be 0, then the object will continue to be at rest, right? So similarly, let's explore the case 2. So pretty much here the potential energy at A, B and C happens to be equal to 0 joules. Simple reason, the height is almost equal to 0 meters. It's just above the ground. Now, what is the potential difference between A and B? And what is the potential difference between A and C? It happens to be 0 joules. Okay, the potential difference between all of this point happens to be 0 joules. Again, a same setup. Things won't move. The ball bearing will continue to be at rest. Okay, to summarize all of this, right? gravitational potential difference, if it happens to be a positive value, we'll see that the object will move. If the gravitational potential difference happens to be 0, there would be no movement. Please keep this in mind. All this will help you understand the concept of current, potential difference, voltage, that is electrical potential difference, and resistance a lot better. Okay, so keep all of this in mind till now. Whatever we learned, this is going to help. So people want to make a note, please pause. This everyone has to, this part. Okay, so, and this part is left to your interest. You can draw and make a note. Again, please concentrate on written notes. It's going to help you guys a lot. I can promise it will be helpful. It is not a waste of time. See, you will spend a lot of time, yes, writing all of this and writing your own thoughts, but the idea and the concept will stay for longer. You need not revise that often. So that's the advantage. You might spend a lot of time now, but you're going to save a lot of time later. So overall, you're going to save time. Okay, so yeah,